Hey guys, welcome back to this series. And just like I promised in my last video, I'm going to be walking you through practically everything you need to know to be very good in meta-analysis. Now, I've actually divided this video in various segments. You can actually skip the timestamp if you want to go straight to practicals. Sure, that's actually allowed. Now, one of the things I want you to know is that I'm going to start by walking you through the interface for the RevMan software. What's RevMan? RevMan stands for Review Manager. So it's actually software we use in performing meta-analysis. Then when I'm done with that, I'm going to also be explaining some kind of theories that we already talked about before, which is some of the interpretation and also some of the variables that you need to get very hands-on knowledge with. And also, when I'm done with that, we're going to go through the practicals. We'll start from the pooled prevalence meta-analysis, then I'm going to look at the effect of intervention, and then I'm also going to check out the diagnostic test accuracy. So this is actually the right video for you if you want to learn practically how to do a meta-analysis. Let's get straight into the lecture and get everything started. Now, before we get straight into the practicals, I'm just going to walk us through some of our slides, some of the things that we're going to be expecting this practical. So even if you want to get more graphs on this, you can just go back to our previous video where we've already highlighted all these particular insights more in details theoretically. But as a matter of refreshner, we'll just want to go through some of the slides again and have more hands-on insights on it. Okay. All right, so that's what we're going to be doing. So first of all, we'll look at the effect models and meta-analysis, just kind of a refresher. Look at some of the types of outcomes. We're going to look at some of the key measures in meta-analysis. Then we'll take a look at some of the step-by-step guide that we can use in performing it, particularly using RevMan. Remember when I started this video, I did mention that I'm just going to be working with the Review Manager software. Then I'm going to walk us through some of the interface of the Review Manager. Then we'll generate some forest plots using some of the examples that we're going to be working with. Then we're going to look at publication bias. We'll look at what are funnel plots. We'll look at how to interpret a meta-analysis result. And then we're going to look at some of the considerations we could have whenever we want to start a meta-analysis, and then some kind of additional components for meta-analysis, then summary of key points and practice exercise. Now, I'm not really just going to be stressing much on the definition of meta-analysis. We all know that the meta-analysis is just that statistical technique that we use in combining results, from different studies, okay? Because the idea is just to provide kind of a summary estimate that's more like a quantified summary estimate that can guide decision making. Now, we'll just have a view of some of the effect models in meta-analysis. We talked about the fixed effect model. When do we usually use it? Okay, so we use the fixed effect model whenever there are some kind of similarities, within the studies. Okay, we're going to look at this, and we have what we call the random effect model, which we did talk about in our last session, where we use this effect model whenever there are some kind of varying estimates, among the studies. Okay, let's say, for example, people who are out for an exercise programs, but then there are different population sizes, or maybe there are also other differences like study designs that maybe we've actually selected studies that we want to use into meta-analysis, and then we now have to do what? Use a random effect model because they have different designs within those studies. Another thing we're going to be checking out during the course of this exercise is what? Some of the types of outcomes that we do have. And we have dichotomous outcomes because when you will be selecting your model, the outcome is something that is going to inform the type of meta-analysis that you're going to be conducting at that particular level. So it's very important for you to have very good understanding of the statistical concepts. Okay, so whenever we talk about categorical outcomes, we're looking at outcomes like yes or no, success or failure, events, outcomes are related to events. Okay, maybe they could be binary, it occurred, it didn't occur, or whatever. Okay, now it's very important. Okay, we've talked about this in our previous session, and then we also have what we call the continuous outcomes, where we look at numerical estimates that are maybe sometimes categorized on a scale. It could be weight, it could be blood pressure, whatever. When you look at all this kind of decimal or maybe numerical quantitative highly related outcomes, then it means what? It's a continuous outcome. So it's very important in decision making. Now, because we are going to be exploring the RevMan interface, it's very important for us to understand the O to A and variance, outcome, put particularly whenever we are trying to pull, you know, estimates, right? We're trying to perform the kind of meta-analysis of prevalence. We should always know when to, choose this particular one. But I'm not really going to stress so much on this. When we are going to be looking at the RevMan interface, we'll get to explain this better. Now, the same thing also is going to happen here, generic inverse variance, how it relates. And during our, RevMan interface, I think we'll get to understand this much more better. But everything you need to know about the generic inverse variance is that whenever you've put studies together, that are trying to combine different effect sizes, or maybe some kind of measurements of units, amongst them, and they've got some kind of varying outcomes. Now, what the generic inverse variance happens to be is that it tries to understand those different effect sizes using inverse of that particular variance. So we're going to actually explain this more in detail. Don't worry, when we explain how to enter data into the what RevMan. Now we've got other types of data types, but I think those are not really going to be important at this stage. Now, another thing we need to understand is what we call the effect measure. Now, remember that when you extract some of this information from various studies, let's say, for example, now you want to collect all the blood pressure from all the studies that you've put together. Now, what kind of effect measure will you use in quantifying them when you summarize them in meta-analysis? That's what I want to talk about now. Now, we have what we call the odds ratio, okay? Now, what is the odds that something is going to maybe happen or not? Okay, depending on the type of, maybe treatment group or control group, that's what's going to determine, the type of effect measure that you're going to use. Okay, let's just say, for example, you're trying to talk about the effect of a particular vaccine, maybe on infectious rates. Now, you want to know what is the odds of those people, recovering and all that. Okay, basically, we've explained all this in our previous lecture, but it's always very important for us to have a refresher about it. But what you need to know is that whenever you are trying to, pull pull some kind of variables from various study estimates, it's always very important for you to know what the effect measure that you want to use in measuring that what those particular parameters. Now, we also have what we call the risk ratio. Now, look at the risk ratio, like maybe you're trying to pull evidence around smoking or maybe something related to some kind of risk. Okay, now you see that risk ratio is an effect measure that is going to be used in judging, the effect of that particular or those particular parameters that you've summarized, or you're trying to summarize, or you're trying to pull together to answer a particular research question. So these parameters, these variables, these objects are actually very important for you to have a very, very detailed knowledge about it so that you will know when to make use of which. So not really serious, we'll explain it thoroughly during our practical. Now, before we actually go through together, I might just want to show some kind of differences between, the odds ratio and the risk ratio. Now, with the odds ratio is often used in case control studies, okay? Whereas the risk ratio is used whenever you're trying to understand exposure, right? And it's usually either prospective or retrospective, which is what cohort studies. Or maybe sometimes randomized trial when you're exposing a particular group to a particular intervention or whatever, or an exposure. The risk, understanding the risk of developing one other thing or exposure to something is really very important, and that's where it differs with the odds ratio. Okay, and same thing actually applies when you want to interpret. Almost similar, like I said, practicals is going to make us really, really, really drawn and very well, aligned to whatever thing we want to talk about. So whenever the odds ratio is greater than 1, that means that the outcome is more likely to happen in the treatment group. And whenever it's less than 1, it means that it's less likely to occur in the treatment group. In the case of risk ratio, whenever it's greater than 1, it means that there's an increased risk in the treatment group. And whenever it's less than 1, that's decreased risk in the treatment group. So just to know this, that odds ratio is good for rare events or when odds interpretation is suitable, or maybe whenever you want to kind of overestimating effect if outcome is common. So why the risk ratio is preferred when outcome probability is clearer. So we're going to actually look at this more in detail. Now there are other ones which we call mean difference, standard mean difference, and all that. Now somebody might be asking, what type of data type does odds ratio and risk ratio apply to? So they mostly apply whenever you're measuring around. As I'm talking about for this now, they usually apply whenever you're trying to measure for binary outcomes, okay, binary or dichotomous outcomes. Whereas whenever you're looking at the mean difference, which basically you're trying to know the difference between the two mean, the two groups on the same continuous curve, it's usually the continuous what variable, all right? So yeah, so maybe when we put studies together like blood pressure, weight, and we're trying to understand the effects measure of them, or maybe the effect, or maybe we're trying to establish a kind of relationship, it's very important for us to know that the mean difference seems to be what appropriate for it. Now we have the one we call the standard mean difference, and it's not really much so different from the mean difference. It's used whenever studies measure the same outcome, but they are trying to use different scales. Okay, so that's why we use the word standard what mean difference. And most times whenever there are so much variations, it's very important for us to use the word standardized mean difference. So these are just what we call effect measures, as simple as what that. So this is, we use it whenever we are making any choice of test statistic or whatever, and we are trying to input our parameters. It's always very important for us to know the effect measure that we are going to use in measuring it. Now, the difference is that when you look at the mean difference and you look at the standard mean difference, the mean difference is usually an absolute difference in the means between the two groups. But, just like we talk about the standard mean difference, the difference in the means, more like whenever there is varied measurement scales. Okay, this one is measuring blood pressure in millimeter mercury, the other one is measuring blood pressure in another scale and all that. So we want to actually get the mean difference. We'll have to use a standard mean difference that is going to accommodate for all the scales. Okay, so whenever there are different measurements, we use the SMD. Whenever they use same outcome measurement, then we use what mean difference. Okay, so this is a kind of example of a research question. What's the mean difference in blood pressure between two groups taking different medications? Okay, whereas what is the standardized mean difference in depression scores between CBT and treatment? So in this depression scores for CBT, there are many scales. Okay, there is the Beckett scale, there is Lantard scale, a lot of scales that are actually used in what measuring CBT. So you need to know that is where you need to use the word standard mean difference. Now we're going to go straight into kind of step-by-step guide to conducting a meta-analysis. And first of all, it's just to open the RevMan project, create a new file, enter project details, and then we add studies by entering data on study characteristics. We enter the study data, maybe the study characteristics and effect sizes, and then we select either whether we're going to use the fixed or effect measure, model. This is our effect model, not our effect measure, right? We're trying to know the model to choose. Okay, so yeah, and then we'll now choose our effect measure. All right, so here we can actually choose either it's odds ratio, risk ratio, mean difference, or standard mean difference. And then we'll now calculate to generate a sum effect, assess the heterogeneity, which is quite very easy to do. We will interpret the results, review the effect sizes. So our interpretation goes through effect sizes, the confidence interval, we're going to explain that, and the p-values to draw conclusions. Now we're going to go straight into the RevMan work. I'm just going to walk us through the RevMan interface. So this is the RevMan app. So if you don't have it, I'm just going to close it and open it again. So if you don't have it, you can actually send an email across. I might want to forward a kind of batch file to you to get this version. But you can always go online and use the Cochrane, library, version or whatever. But then there are also other alternative softwares like our programming language that can be used in performing a meta analysis. Okay, but for me, I'm very conversant with RevMan and very good with it. Now, this is the interface of the review manager software. Okay, now right here on this button, this is just a welcome screen. Nothing, it doesn't really show anything, and you can create a new review by clicking here, and then you can want to go to next. Then when you go to next, you might choose the type of review. But before I go there, I might want to explain what this the dashboard is all about. So this is where you can create a new file. Alternatively, from where I came through, you can actually create a new file here by clicking new, and when you click new, it brings this out. Okay, so I can just close this. When I click on file and I click on new, it brings this out again. Okay, and now here is to edit. If you want to edit anything, yeah, if you want to format anything, yeah, if you want to view your notes, if you want to track your tools, maybe kind of insert tracker changes, maybe if you're working on a collaborative project with somebody else and you want to track some kind of changes, and that's what you can do here. There are other things you want to do, maybe align your tables, delete the merge, all that, maybe for categories of included studies or whatever table you've got in your work, then yeah. Now this is actually where you can align the windows, whether you want it horizontally, vertically, or whatever. Okay, and here if you've got any kind of question to relate to Cochrane group or whatever, you can always just make it here. Okay, cool. Now this is just the interface. Now the next I'm going to do now is I'm going to click on next. Now one of the things that is very important is that we have several types of reviews. Okay, we have interventional review, we've got diagnostic test accuracy, we've got methodological review, we've got overview of reviews, which is usually known as umbrella review, we've got flexible reviews. Now, depending on the type of topic you are working on, you might want to choose the type of review that's applicable to you. Now, what I'm going to do right now is this. I'm just going to walk us through the remaining parts of this slide, and then immediately I walk us through the remaining parts of the slide. Then we're not going to look at some kind of examples of research questions that I've already selected, and then we'll now explore the interface much more better. Now, I already just talked about the fact that we have some sections in the RevMan interface. We've got the protocol, data analysis, where data entry and calculations are being performed. We've got the tools panel, which I did show us. We've got the characteristics of institute studies that is going to show in the main dashboard. We've got forest plots, visualization. We've got be able to enter, and select, effect measures and all that. Okay. Now we also got what we call forest plots. I'm just going to talk a little bit about it before we now go straight into practicals and have a much more deeper look. Now, there are a lot of things that are contained in the forest plot. We've got a diamond, we've got squares, I squared present, we've got horizontal lines, which we call confidence intervals. We've got the diamond overall put estimate, and yeah. Now, also, there's something we call the publication bias, and when we talk about the publication bias, we're trying to explain, the rigorousness of that overall evidence, okay? And some of the conclusions here require some kind of, what we call the Eggers test. Usually once you perform your meta-analysis, you should be able to generate you should be able to conduct what we call the Eggers test, to ascertain, publication bias, okay? To know, how evenly distributed, are some of those, scatter plot around the graph, and these are some of the things we're going to also explain. And you remember we talk about publication bias is something that occurs usually when there's a kind of skewed practices, whether publication bias or what exactly happened in terms of doing the study collection that might have made the authors to miss out on potential studies. Now, this is what we represent through funnel plots. Okay, so when we talk about publication bias, and when we perform the Eggers test now to ascertain the publication, if there are some kind of flaws in the selection process. Now, what we call the plot that we generate is the word funnel plot. So this is determine the asymmetry of perform statistical tests like we talk about a gas test. Okay, yeah. Now we're also going to talk about how to create this. Enter the data in RevMan, go to data analysis, select funnel plot from tools, a lot of them. So we'll talk about all this and also how to interpret it. And now we're also going to look at how to interpret meta-analysis results. What are some of the things to consider? You need to consider the confidence interval. You need to also consider the p-value, 95% confidence interval. You need to consider the effect sizes, and you need to consider the risk ratio. So these are actually some of the things that are quite very important for you to consider whenever you are trying to interpret the meta-analysis. Now, some kind of further clarity on meta-analysis is that we'll talk about is what we call heterogeneity. Okay, so it's very important we understand this now. Now, that is usually what you get to be saying I squared. Now, what this illustrates is how different are the studies. Now, whenever the heterogeneity cutoff point is usually 50%, whenever the heterogeneity is less than 50%, it means that there is some kind of there is no significant one heterogeneity, and there are kind of some similarity. So, right? Or there's significant heterogeneity rather, when it's less than 50%, and when it's greater, then there is no maybe heterogeneity and all that. So more like studies are varied, random effect, models might be more suitable. So yeah, that's it. Now, what are some of the considerations we need to put in place before starting a meta-analysis? First of all, we need to define our clear research question. We select studies. We we extract the relevant data. We insert it for search. Check it out for risk of bias. Then we'll assess the heterogeneity. User is going to measure it. We'll model everything, all the choices. Fix either random or fixed effect that we are going to go for, and then we write properly, then publish. Now, some kind of additional components for a meta-analysis that we might want to talk about is what we've talked about heterogeneity already. We have subgroup analysis. Subgroup analysis is usually performed whenever you want to go deeper, particularly with respect to an area that you've explored. Okay. We've also got what we call sensitivity analysis, where we can sometimes remove the highest and lowest, studies to know if there are significant changes. And there are actually lots of, components that we've got to look at, but I think a couple of them deserve just a few. Now, what are some summary of key points from this very quick exercise? Is the meta-analysis combines data from the summary effect. The RevMan tool is used for entering data, running analysis and visualizing results. Other tools are like SPSS and Python. And then we also understand that, that the funnel and forest plots are key, particularly in the graphical interpretation, or maybe they're some more like they are key graphical tools, that are used for interpretation. And interpreting results, you need to look at the effect size, you need to look at the confidence interval, you need to look at the p-value. This is actually very important for you to make better conclusions. Now, we're just going to start with something, perform a kind of meta-analysis on a data set, interpret a forest plot, and check for population bias. Now, I'm just going to go straight in. Now, the first thing I'm going to do before I get done with this is I am just going to open the RevMan phase, right? Now, let's have a look at a kind of something. Now, these are some of the recent meta-analysis that I've conducted. Now, I could just open this where I compared, Kaplan-Meier versus placebo, and this is what the result looks like. You find out that everything is properly written. You can see all these forest plots that are actually inserted inside of it. Now, the next thing I'm going to do right now is I'm just going to show us completion of the interface of Review Manager. Then we could just explore some practicals straight away. Now, when do you choose interventional review? You're going to choose it if you have a topic that like Cipro math versus Tambin saw. Okay, and that could be a suitable research question for you to choose. But then some of the key ones we have is interventional, uh, diagnostic, and put prevent. But whenever I want to do put, if what you're trying to do doesn't fit here, you can always do drop some messages here. So I'm just going to go to next. Now the next thing I'm going to do now is I'm going to enter a term here. Now let's assume I'm just going to show you. Okay, this. Let's assume I'm working with this Excel sheet. I've already. Okay, look at this. Let me show us another one. Now look at this. Okay, you can see Chen, Cronen. These are all studies that we've selected. Okay, and so I could just open this. Now this is my topic: effectiveness of locking fixation, right? Inducement of humeral fracture in patients. So I could just copy that, Control C. I copied that with Control C, and then I'm just going to say, okay, instead of me pasting it there, let me just paste it. So I'm going to select this button. I'm going to Control V. I'm going to go to next. Now, when you go to next, now remember, let's go back here now. You can choose anyone. You can do paracetamol versus placebo for headache. You can do ampiclos for pregnant women in Nigeria. Okay, so depending on how you want to shape it, it's all the same, right? It will all take us to the next phase. Now, when I come here, if to choose protocol, what it means is that it's going to lock out some interface for you. Now, let's try that. Let me try by choosing protocols. I'm going to click on finish, and you can actually see that this is another interface that you don't get to know about. Now, right now, you see this is my topic. I can still edit and add anything I want to add. That's why I say it doesn't really matter. And this is just the protocol. I mean that I can equally write here and collaborate. Now, what is striking here now is that I cannot see, I can't be able to check that analysis. Now, let me explain this part now. Now, look at this interface like a document template for you to do your systematic review, okay? Now, all these areas, now you can decide to write here. You can say, okay, Nigeria is a country, blah, 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 right? Now, the idea is that when you are working here, you can have somebody to collaborate. For some of us who might be installing this application for the first time, they might get where to ask you, do you want to stay for Cochrane or non-Cochrane mode? So if you choose Cochrane mode, then in that case, you might have to be matched or something. Okay, but in this case, I'm working on non-Cochrane mode, so that's why even if I can't really just type in anything here. Now, if you look at the table, you'll find out that here now is the protocol information. You'll see that discussion is not clickable. Just think about it as your proposal in your project. You can't be writing the results when you've not finished with your protocol, okay? So now, that is what this phase is all about. Now, to change it, I'm going to click here. Okay, so I'm going to click on full review. Now I'm not at the protocol stage. I'm going to click on full review. I'm going to click on okay. Now notice what's going to happen now. The data analysis now can now be clickable. Means that I can now perform what? Data analysis. Now let me explain. Now this is what we call the title. This is the review information. This is the main text. Now this is the tables. Okay, some of the tables that you might want to include. Maybe you can just manually write them in. The study summary of findings and a lot of them. Now, you also got the studies and references. Now, what does this mean now? This is where you enter your studies because you've now gotten information from several places. Now, you need to enter it. So that's where you're going to enter it, okay? So if I click on this here, now if I click on this key, it's going to give me studies to enter. I can enter included studies, I can enter excluded studies, I can enter studies that are waiting classification, I can enter ongoing studies. So depending on my choice, okay? All right, so now the next one is what? Other references, okay? It might not really matter. Now then the next one is what? Data analysis, okay? All right. So what it means here now is that when I right click, I can add comparison groups that I want to compare. And when I add them, I can actually run around it, maybe do one or two things. Okay, cool. Now, what we are going to do now is very simple. Now, the first step, remember when we go back to the slide, where is the slide? When we go back to this slide, I think in the previous stages of the slide, you'll find out that we talked about some of these steps to start. Okay, and I will say that you need to write a protocol first, but we don't really need that now. We've got data and analysis and all that. So now the very first thing we might need to do is to add studies, right? So now let's assume I want to work on this now. Effectiveness of locking fixation in the treatment of humeral fracture. Now, basically, the first thing I'm going to do now is I'm going to come to Google. Some people, yes, you have to go to Google, search out studies. Now, already I have 7 studies here. I can just click on this. Okay. I'm going to click on another random one, number 6. Okay, so I'm going to click on, okay, so this is one of the studies and this is it. Okay, now that is one, right? So meaning that it's expected that for you to be at this stage of this lecture, you already know how to select studies, you know how to conduct at least search and systematic review, okay? Now what this means is that you've selected the studies that met the criteria, and now let's go back to sheet. And now the first thing, okay, now the first thing you're going to do now is when it comes to RevMan, if you're working with RevMan, we're going to go to studies, okay? That's the first thing we will do. Remember, we said we'll include studies first, and then, yeah, so let's say you're working with 30 papers. You must have to include all of them. And how do you include them? We're going to make that very simple. Hold on. Now, here are actually some of the included studies, right? So I'm just going to make it very simple. So now the first thing you might do now is I'm going to copy this. This is chain 219. Now what I would do is when you come to RevMan, you can just click on add study. You put chain at for 2019. Now you see how I entered it. And the next I'm going to click on is next. I'm going to click on next. 2019 automatically. Next. Next. Now it has added. Okay, so if I tap here, Now the next one is we're going to now click on this add study. We'll go to the next one, Cronlen. We'll pick on Cronlen, and we'll go to okay, finish. I think the study just got finished now, so this is the first one, right? So click on add study, Cronlen et al. 2015. I don't know if that's correct. Just want to be sure. 2017 actually. 2017. So instead of going next, you can just press finished. Okay. So you see that we're trying to make sure that all the studies are showing here, and then the next one is remember you right click. Okay, so you click on finish. Okay, so basically, I think we're working with these two. Okay, I think I could just add one more to make it four. Let's just be fast with that. Ziegler et al. 2019. I'm just going to come here. I'm going to click on finish. I'm going to click on add. Well, go to the next one. We're almost there. I think you just left with all right, so basically, I've entered all the studies. And remember that basically what it means is that before you start your meta-analysis, you must make sure you queue in all the studies. Okay. When you are using R software, it might not really apply this way, but it's very, very important in RevMan. Now, remember we just entered studies. Now, the next one we'll have to enter is what? An outcome. Now, how do we do that? We'll go to data analysis. We'll right click, add comparison. Now, what do I mean by that? Now, let me go back to the research question. Now, if you look at this question here, we're trying to understand the effectiveness of locking fixation versus placebo. Now, it can be anything. It could be antiretroviral therapy versus highly active antiretroviral therapy, right? So that's the comparison. So this is the comparison. This is what we're trying to compare, all right? And for us to know if this locking fixation is effective, there will be outcomes, and these are the outcomes. Do you understand? So the more like this is a meta-analysis. What makes it a meta-analysis is that we're trying to compare this intervention with this intervention based on these outcomes. And some of these outcomes, some of them are continuous, some of them are dichotomous. Okay, so I'm trying to make it look very easy now. But what do we do? First of all, we add the comparison. Okay, so I'm going to copy that, and I'm just going to put it here. I'm going to maybe finish. Okay, if you have another comparison, you can still add it, but I think basically this is the comparison where I am trying to use to answer my question. Okay, good. Now I'm going to click on this. Now when you click on this, now you get a comparison, right? Now what you can do now is to add outcomes under it. Now I'm going to right click on add outcome. Now you remember when we started this session, we talked about dichotomous, continuous, OE, generic, invalid variance, and all that data, right? So this is the types of outcomes that we have. If you're trying to understand the pooled estimate of something, that's going to be there still, but now the type of outcome we'll choose is going to be different. But all the same, let's go with what we have for this topic, okay? Now, these are some of the outcomes: functional outcome, fractional linear rate, complication rate, pain, range of motion, dash. Now, the next thing we're going to do now is to now match out the outcomes, okay? Now, how do we match out the outcome? Let's say, example, we want to go for the functional motor, maybe we want to go for a functional outcome. It's a continuous outcome. Remember, good practice is that whenever you match out all your outcomes, you need to arrange them in a table and then now state how the study is actually dictating that. So I'm just going to come here, go for continuous. I'm going to go to next. I'm going to type the outcome. This is what it is. Now there's something we call group labels. Okay. Now what group labels means now is more like the table that you're going to use in entering your terms. Okay. So at the other side, at the first label, I'm going to call it locking fixation. And then I might say leave it as control. I'm going to go to next. Now when you go to this part, now this is where you now choose your analysis model. Remember, we differentiated it from our effect measure. All these are all effect measures: odds ratio, risk difference, mean, and all that, right? So I think there might be some kind of differences here. Well, it doesn't really affect so much. I can choose a random effect, mean difference, maybe if they are having the same scale, okay? Then I'm going to click on next. Now, when you come here, you need to leave it, totals and subtotals. Don't touch anything there. You need to actually leave your confidence interval at 95, but let's gonna push it to 99%. That's it. Just essentially leave it all this way. We'll move to the next. Now, this is where we now position what we call our graph. Okay. Whenever you've got an intervention, it's usually best practice you keep it at the left side. So I'm going to change this to locking fixation, and then here I'm just going to call it favors placebo. Okay, so I don't think I have anything to touch here. You leave the ID, everything here same way, and you go to next. I think I can click on finish. Now, what I'm going to quickly do now without wasting so much time is I'm going to enter the studies that are actually comparing, functional outcome as a measure, versus placebo. Now, I've already drafted that out, not to waste so much of time. Now, we've got Chan et al., Gracite, Platt, and Zhu. Now, how do we bring these studies in? The next thing we'll do is we're going to come back here. We'll click on this plus arrow. Now, let me explain this interface a bit now. Now, this is where we add studies. When I click on it, it gives me avenue to add studies. Now, this is where we can change the effect measure. Okay, we can change it from standard deviation to mean difference to whatever thing I want. Now, this is where we change the analysis model. Either it's a random effect or fixed effect. Okay, you can just tap it. By tapping it, it can easily change. Now, this is where we generate the forest plot. Okay, when I click on this, it generates a forest plot, but there is nothing in it because I haven't plotted anything. All right. And if I want to copy my first plot, I can copy it from here or wherever. Now, the next thing we're not going to do now is we're not going to enter those studies. I'm going to click on the plus sign. Remember, in our data table, it could be an Excel sheet if you're using that. We've got Chan, Graystar, Plaster, and Zoo. So we're going to go there. So Chan, I'm going to click on it. Now, when I click on it, I will hold my Control key. We've got Plat, Graystar, and Zoo. Okay, that was what I did. And I think I can just click on Finish. That should still settle that. So these are the studies. Now it means that inside of those papers now, you need to be good with statistics. There are some certain insights that you need to extract. You must have extracted the mean, and extracted the standard deviation, if at all it's there, and the total, the sample size. That's what this total is all about. Now you look at this now, you see that this is the group label. You see that this is the graph that points to where the particular intervention is favoring or not. Now basically, so what I might want to do here now, I might want to just insert those parameters here right away so that I can actually see my forest plots. Now, what do? I can just come here, copy this, I Control C that. Okay, you can actually decide to insert it one by one, that's still fine. And I could just paste that, okay? So I'm going to assume that that has been, pasted, okay? Now, if I look at this particular data now, okay, now some of this you might realize now is that this is your forest plot, okay? This is your forest plot. And the first thing you might want to do now is to connect your final plot. You can just click on this and look at that. So I'm just going to click on this. I'm going to click on the forest plot. I'll click on copy, and maybe I might just take it to my notes. Now, because this is greater than 1, right? Now, looking at my, I'm going to explain the forest plot right now. And when you look at this forest plot now, you see that we've got the put confidence interval, and the mean difference is quite greater than 1 and all that. What I might want to do now is, if you look at these parameters here, you look at the diamond is sitting here, you see some of the the confidence interval stretching through those points. And also the heterogeneity is 13%, meaning that there might be quite similarities among the studies, and that means there is a significant effect. So it means that based on functional outcome, was it based on the functional outcome, locking fixation might seem to be very effective. So that means I have to reposition, my forest plot chart. That's where my locking fixation should be at the right and not on the left. So to do that, I'm going to click on settings, properties. Here I'll go to analysis details. I'll walk straight to graph. I'm just going to lock in fixation, and this is plausible. Okay, so I'm just going to apply these changes and say okay. So yeah, that's it. So I'm going to copy this, and yeah, and yeah, I'm just going to paste it. All right, so yeah, that's it. Now in our next session, I'm going to be explaining some other things you need to get, some of the interpretation, how to also perform a pool prevalence so that you can be able to run a prevalence meta-analysis and basically understand much more deeper insights, based on what we are doing. So, congratulations, you are quite on the right path, and yeah, that's a very big win for you. Yeah, bye bye.